Hey, so in this video, I'd like to cover the differences between elements and compounds, and also heterogeneous versus homogeneous mixtures. All right. So first of all, an element is any substance where that substance is made of only one single type of atom. All right. So they come in a couple different forms, and let's just go over a couple different varieties. All right. One example would be something like helium. All right. So if you have a helium balloon. All right, inside of that balloon is just a bunch of single helium atoms. All right, and one thing that you would recognize is that helium is a gas. All right, and so what that means is that there's actually space between those helium atoms, so they're not touching each other. So that's why I've shown these as single atoms which are spaced apart. All right, another example would be pure oxygen. All right, the difference is that even though oxygen is a gas, which means that these particles are spread out from each other, an individual unit of oxygen is actually a pair of oxygen atoms. All right, that's why oxygen's formula is O2, because it actually exists when it's in its elemental form as two atoms which are bound to each other. All right. So notice that within this unit right here, you have nothing but one type of atom. All right, they're all oxygen atoms. It's just that they happen to exist as pairs of oxygen atoms, whereas the helium atoms exist as individual helium atoms. All right. Um, one other type would be metals. All right, pure metals are going to be, hopefully you realize most metals are going to be solids at room temperature, and therefore their particles are going to be touching each other. So if you have aluminum, you just have, a lot of aluminum atoms. All right. Another type would be of element that would be a solid would be carbon. Carbon gets a little complicated because it comes in a couple of different forms. A diamond is one example of pure elemental carbon. Coal is also pure carbon. All right. Graphite, the material that makes up your pencil lead, is pure carbon. All right. So again, elements are things that are only one single type of element. Right. A compound, in contrast, is a substance consisting of two or more chemically bonded elements in a fixed ratio. All right. So these are three common examples of compounds that you probably are somewhat familiar with. All right. H2O. All right. Water. All right. Consists of one oxygen chemically bonded to two hydrogen atoms. All right. So these right here, each one of these things right here is a molecule of H2O. All right. And notice that there is a fixed 2-to-1 ratio. All right, that's what makes it a compound. All right, carbon dioxide, whose formula is CO2, is a carbon bound to two oxygen atoms. All right, and one last example would be sodium chloride. All right, which is you can tell from the formula here, it's one sodium per one chlorine. All right, this is a little bit oversimplified for this substance right here. And we'll get into more of why that's oversimplified when we start talking about different types of bonding. But these would be three examples, of compounds. All right. So by a large margin, most materials in the world don't exist as individual compounds or individual pure elements. They actually exist mostly as mixtures. All right. So a mixture is going to be just some combination of elements or compounds. All right. And I mean, usually mixtures are going to be mixtures of a lot of these things. All right. But there's two major forms of mixtures. One is going to be a homogeneous mixture. And the other one is considered a heterogeneous mixture. All right. So a homogeneous mixture is a composition whose composition is uniform throughout the mixture. So if I just wanted to represent that, take a look at these particles right here. So one thing I want to point out is that these, each one of these things right here could either be a compound or an element. All right, so I'm not intending to imply that this is a pure element right here, and this is another pure element. All right, this could be a water molecule, for example. All right, but the main thing is that notice that throughout this right here, it's the same all throughout. If I circle this little area right here, you're going to have about the same number of red and blue dots as you do over here. All right. A heterogeneous mixture is one where that composition is not uniform throughout. All right, so notice you've got the same types of things over here, but things tend to be bunched up in little areas. All right, so the composition, if I were just to select a random area like this right here, that's not the same composition as if I selected this random area over here. So notice that, a homogeneous mixture, and by the way, sometimes people pronounce that homogeneous. Notice that things seem to be completely mixed, all right, where it does not seem completely mixed all the way down to that atomic level when you have a heterogeneous mixture, all right. So a good way to practice this is this example right here, and I provided an example, a copy of this file on my Canvas page, so if you want to take a look at it, you can. But there's 8 different choices here. Either it's a pure element, a pure compound, a heterogeneous mixture of elements, homogeneous mixture of elements, and you can read the rest of these. But you'll notice that there are 8 different choices down below. All right, so your job is to try to select what each of those would represent. All right, so feel free to pause the video right here and see what answers you come up with. And in a few seconds, I'm just going to go ahead and go over the answers. All right, so when you're going through this, one thing that might help to do is just to kind of label some things. So I can look at this right here, and I can tell that that's an element. And I'm just going to use, from here on out, I'm just going to use element, an E and a C. This is a compound. All right, but the thing is, are they thoroughly mixed or are they in their separate locations? They're in their separate locations, so this would be a heterogeneous mixture of element and compound. All right, in this one right here, both of these things that we have here are going to be compounds. All right, but notice that they're completely mixed. All right, so this is going to be homogeneous mixture of compounds. All right, so in this next one right here, notice that everything in this is the same, and these things are compounds because they're more than one type of atom. All right, it's each unit is a 1-to-1 ratio of different elements. All right, so so this would be a pure compound. All right, in this one right here, that right there is an element, but that right there is a different element. All right, and notice that they're completely mixed. So this would be a homogeneous mixture of elements. All right, and let me see the way so they, and notice for it to be a homogeneous mixture of elements, the elements have to be different. All right, this would be one type of element. This is a different type. All right, here, the red one is an element because those are both the same atom, so that would be an element. This right here is a compound. All right, and notice that they're completely mixed. So homogeneous mixture of element and compound. All right, this one right here, this is, notice that in this entire square right here, you have nothing but one type of atom. So this is a pure element. All right. In this picture right here, this material right here is an element. This is also an element right here. So, and notice that they're not completely mixed. You have one of the elements over here, and you have one of the elements over here. So this is going to be a heterogeneous mixture of elements. All right, and the last one, this is a compound right here. This is a compound right here, and notice that they're not uniformly mixed. So hetero mixture of compounds. All right, so hopefully that makes sense, and that's it for this video.